Now let's focus in on the mid-latitudes. Do we see a west to east pattern where we are? So we're up here in the northern hemisphere. And do you see a general speaking a pattern in which things are moving from the west to east? And you do. You see that also very clearly in the southern hemisphere. Keep in mind, southern hemisphere has less land, particularly in the mid-latitudes. In land, I mean, it does a good job of disrupting all of what would be normally natural. If there was no land, these patterns would just be scooting right across. There wouldn't be much variability. So, do we also see low pressures migrating from west to east? Because another characteristic of the mid latitudes is what we have these low pressure cells. And these low pressure cells, or these low pressure areas, because they're in the northern hemisphere, they should be spinning counterclockwise. And so, do we see those? And so, we see one right there, counterclockwise. There's counterclockwise. It's probably a hurricane, which are extreme examples of low pressure. There goes one. There goes off another one. This is high pressure, clockwise. Low pressure. Oh, there's a low pressure spinning and hitting the coast. Another low pressure spinning and hitting the coast of the United States here. And so these low pressures, essentially what ends up happening is you have a low pressure come through, bringing with it stormy weather, cloudy weather, chances of rain, followed then by a high pressure. It kind of follows its path. A high pressure then comes in, brings with it changing wind patterns, that clockwise flow, but also dry conditions, and then a low pressure falls behind. And so when we look in the northern hemisphere, in the mid latitudes especially, we see not only seasonality because of all those things we mentioned before in the semester, but we also see changing day-to-day patterns in weather, and that's because of the mid latitudes, because of those migrating low pressure centers that come through and bring with it changing weather from one day to the next. Finally, although I'll be talking about this next, the polar high pressure. You'll notice the polar high pressure up here in the northern part of this particular map, but also the southern part, you don't see much water vapor at all. That's because high pressure. We associate high pressures with dry. They're essentially the winds are essentially blowing out all of the moisture, the water vapor, essentially causing it to go a different direction and not stay there. And that's why in both the Arctic and the Antarctic you find some of the driest conditions you'll find anywhere in the world.